Okay, let's look at geometric sequence series. In a geometric sequence series, this means it is a common ratio. Okay, so I'm going to look at all of the terms and divide them. So I'm going to take -6 divided by 3 gives me -2. 12 divided by -6 is -2. -24 divided by 12 is -2. And 48 divided by -24 is -2. These are all the same, so it is geometric. There is a common ratio. Okay, I'll do the same thing over here. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. 24 divided by 16, it's not 2. It's 3/2. These are not the same, so it is not geometric. Okay, so let's see. If I need to find the formula for the nth term of a geometric sequence, the formula is a sub n equals a sub 1 times r to the n minus 1. Okay, so a sub 1 is 7. My common ratio, it tells me it's geometric, so I don't have to check all of them. It tells me that my r is equal to -21 over 7, which is -3. So now I just plug these values in. So a sub n is equal to a sub 1, which is 7, times -3 to the n minus 1. And that would be your answer. Okay, same thing, same formula. A sub n is equal to a sub 1 r to the n minus 1. They give us a sub 1. The r is the common difference, or excuse me, the common ratio. So r is equal to 9 divided by 12, which is 3/4. So I'm good to go. So a sub n is equal to a sub 1 times 3/4 to the n minus 1. Okay, find the sum. All right, now there are two different ways that you have to do this for geometric. Is if it's finite, if it ends, if it goes from 1 to some number, this is finite, which means this is the partial sum. And the formula for that is the sum of the n terms is equal to the first term times 1 minus r to the n divided by 1 minus r. If it is infinite, there is a condition here. The absolute value of r has to be less than 1. So whatever your common multiplier is, that has to be less than 1. And that just kind of makes sense. And then you use the formula that the sum is equal to the first term divided by 1 minus the ratio. Okay, so let's do this one first. So in order to put into this formula, I need to know how many terms there are, the value of the first term, and that's it. Okay, so let's see. So I need to find my a sub 1. So a sub 1 is equal to 3 times negative 5 to the first. So a sub 1 is equal to negative 15. I also need my r. R is negative 5. And I need my n. This tells me that n is 12. So now I just plug them in. Okay, so the sum of the first 12 terms is equal to negative 15, my a sub 1, times 1 minus my r to the n, all divided by 1 minus negative 5. Okay, so I'm just going to clean this up just a little bit. So this is negative 15 times 1 minus negative 5 to the 12th divided by 6. Now when I put this in my calculator, this is going to be a huge number. So let's see what I get over here. All right, so let's turn it on first. So I have negative 15 times 1 minus negative 5 to the 12th, all divided by 6. And it is a big one. Okay, so I'm gonna move this out of the way so I can write it down and put commas in. 610,351,560. And that's what your answer is. So that's the partial sum. Okay, so since this is infinite, the first thing I want to do is look at my r. So I see here, because otherwise it can't be done. This is my r. R equals 2/3. The absolute value of 2/3 is less than 1, so the sum exists. Okay, so that tells me that I know my r. I need to find now my a sub 1 equals 6 times 2/3 to the first. So a sub 1 is 12 over 3, which is 4. So all I need is a sub 1 and r. So I plug this into my formula now. So the sum is equal to a sub 1 divided by 1 minus 2/3. So this gives me 4 this is 3 over 3 minus 2 over third divided by 1/3, which is 4 times 3, so the sum is 12. Oh my gosh, we're on our very last problem of a very long review. All right, so this is a geometric series. So let's see what we've got to do here. We've got to do all kinds of things here. All right, so since this is a finite series, the formula I'm going to use is a sub n equals a sub 1 r to the n minus 1. So what I know here, I know my a sub 1 is equal to 2. That comes directly from there. I know that my r, I use these two, is 6 divided by 2, which is 3. But I need to find my n. So I'm going to have to find n. Since my formula for this, it requires the partial sum is a sub 1 times 1 minus r to the n, all divided by 1 minus r. So I know my a sub 1, I know my r, and now I have to find my n. Well, using this formula, I can solve for n because I know what a sub n is and I know what a sub 1 is. So to find n, I know a sub n is equal to 13,122. So using this formula, I can say 13,122 is equal to a sub 1 times my r to the n minus 1. Okay, so I divide both sides by 2. So that gives me 65, 61 is equal to 3 to the n minus 1. Now, with any luck at all, well, I know it has to be if that's a common multiplier. This has to be a multiple of 3. So I'm just going to play with it. Now, you can do the breakdown, but I just played with it and found 3 to what power? I just started with 3 to the 5th because I'm not really familiar with my powers of 3. So 3 to the 5th. Okay, let's try 3 to the 7th. Okay, that's getting closer, so let's try 3 to the 8th. Okay, so there you get it. All right, so I know that 3 to the 8th is equal to 3 to the n minus 1. Since this is an exponential equation, if I can get the bases the same, the exponents are the same. So that means 8 equals n minus 1, so n is 9. So I've got my a sub 1, I've got my r, and I've got my n. So now I can just plug this all into the formula. So S sub 9 is equal to 2 times 1 minus my r to the n, all divided by 1 minus, and r is 3. Sorry about that. I should have put a 3 in there. So S sub 9, and I just put this in my calculator again, is 19,681. Okay, last one here. This is an infinite sum. So that means the absolute value of r has to be less than 1. Well, in this one, r is equal to 5. So the absolute value of r is not. So r is not less than 1. So no infinite sum. Now again, this kind of makes sense because if you've got let's compare it with the one on the prior page. Why are we able to do that? Okay. Because if you're summing these, as you take, if this is less than 1, as you take anything less than 1 to a power, it gets smaller and smaller and smaller. It becomes 2/3, 4/9, 8/27 until it eventually goes to 0. So you can find that sum. Eventually you're not adding anything to it, so you have a number. If it is infinite, every time you multiply it, you're multiplying it by 5, which means every element gets larger and larger and larger and larger, so there's no way you can add them all up. And every term, well, you'll just be able to add more. All right, so that's the end of the review. Good luck, everybody.